أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Our today's topic is continuous probability or Z-score. What is a Z-score and how do we calculate the Z-score? What is the formula for Z-score? And then the practical problems, the exercises for a Z-score. So let me show you the presentation first, and then we will be discussing it in detail, all the slides one by one. Examples of continuous probability distribution. Objective to understand the normal and standard normal distribution. Now, introduction to normal distribution. What is normal distribution? Why study normal distribution? So there is a reason why do we study the normal distribution. Although few data distribution are precisely normal, many resemble the normal distribution, some very closely with normal distribution. The sampling distribution of any distribution is a normal distribution provided the sample size is large enough. Used in estimation in inferential statistics, for example, hypothesis testing is a statistical model. The shape of a given normal curve results from different values of mu and sigma. Mu, mean of the population, and sigma, standard deviation of the population. The mean mu determines the midpoint, and the standard deviation changes the shape. It affects the spread or the dispersion of the scores. So with the value of sigma, if it is more, that will bring more disperse or more spread. And if it is a narrow one with a smaller value, that will bring the values closer together. The larger the value of sigma, the more dispersed the score. The smaller the value, the less dispersed is the course. The normal distribution, changing mu shifts the distribution left or right. And sigma increases or decreases the spread. Let me explain it on the board. Like if your mean is 50 and your standard deviation is 10, it may have this sort of curve, mu, and then the standard deviation, which is 10. If you increase this, this will give you a curve like this. If you further increase it up to 30, it may give you a curve like this. And if you increase or decrease this 60 or 80 or even 99, or even you can decrease it 44 or 30. So that will change the curve like this. It will be shifted towards the right or the left. That is what the difference changes in the curve because of mean and standard deviation of the population. Here you can see this is a bell shape. This is another bell shape. This is another bell shape. So over here, it can give you a better picture. Mu is 52 and standard deviation is 12. So you have this curve. And if you increase the sigma and the mu remains the same, so that will give a spread to the curve. It will be like this. So this spread is because of the increase in the standard deviation. Now the properties of normal curve, any properties of normal distribution, it is bell shape, it is asymptotic. Bell shape, asymptotic, perfectly symmetrical, mean, median, mode are in the center of the curve. Half the values lie on each side when it is cut into half at the highest point. It has got two determinants, mean, mu, and standard deviation, sigma. Can further be explained like this. symmetrical, 50% of the data over here and 50% of the data over here if you cut it. It is continuous means most of the time it deals with continuous variable. The bell shape, it is the bell shape. Mean and median mode, they are taking the same place. Mean is equal to median is equal to mode. And it is determined by two parameters, the mean mu and the standard deviation sigma. So these are the two parameters through which you can determine the normal distribution. The beauty of the normal curve, the empirical rule, the experimental rule, when you do an experiment, no matter what mu and sigma are, the area between mu minus sigma and mu plus sigma is about 68%. The area between mu and minus plus 2 standard is about 95%. And around the mean, if it is 3 standard deviation, it covers an area of 99.7. Almost all the values fall within 3 standard deviation except few outliers. So let me explain it further. This is a bell shape. And this is the mean. If you go around the mean at 1 standard deviation, that will cover 68% of the area. If 2 standard deviation, that will cover 95% of the area, and at 3 standard deviation, it will cover 99.7% of the area. And the rest of the area, if they fall over here, the values, they are said to be outlier. This is further explanation, 68%, 95%, and 99%. If the mean is 66 and standard deviation is 11, so experimentally, if you make a curve, that will cover 68% of the area at 1 standard deviation, at 2 standard deviation, this area is 13.5. If you get together this area and the whole area, that will become 95%. And this one area is 2.35%, 2.35%. If you add up and then add up all these 3 areas and all these 3 areas, and then the total, that will make 99% of the area. How good is rule for real data? Check some example data. The mean weight of the 120 runner, 127.8, and the standard deviation is 15.5. Then experimentally, 68% of 120, that becomes 82 runners. It gives you the number of individuals that fall within 1 standard deviation. And in fact, 79 runners fall within 1 standard deviation, 15.5 lb of the mean. This is standard deviation. So hypothetically, that becomes 82 runners. In fact, 79 runners fall within 1 standard deviation. Now let's see. At 1 standard deviation, at 2 standard deviation, and then at 3 standard deviation. Example, suppose set score roughly follows a normal distribution of the US population of college-bound student with range restricted 200 and 800, and the average math set is 500 with a standard deviation of 50. Then what percent of student will have between 450 and 550? And another is what percent will be between 400 and 600 and between 350 and 650. 68% of students will have score between 450 and 550. How? If the mean is 500 and a standard deviation of 50, let's do it. Mu is 500, standard deviation is 50, and if x1 450 and 550, 400, 600, 350, and 650. So 450 and 550. And x2 is 550. So calculate z score. Z is equal to z1 x minus mu for sigma. X is 450 minus 550 minus 500 over 50. That will become minus 1. And z2 will be equal to x minus mu or sigma. That will become 550 minus 500 divided by 50, which will become plus 1. So if you draw a curve over here with 1 standard deviation, minus 1 and plus 1, 0.3413 is the area covered by 1 standard deviation in the Z table, 0.3413. And when they get together, they make 68.26%. So that is experimentally proved that whenever a population is normally distributed, to plot a curve, 68% of the area or values fall within 1 standard deviation. Now the other examples have been solved for you people. 68% of the students will have score between 50, 95% will be between 400. If you calculate 400 and 600, and then 350 to 650, 99.7%. The standard all distribution can be converted into standard normal curve by subtracting the mean and dividing by. This is the formula. Somebody calculated all the integral for the standard normal and put them in the table. So we never have to integrate. Even better computer now do all the integration. The z-score tells us how many standard deviation are there between the selected score mean x and the mean. The definition of z-score, it gives us z is equal to number of standard deviation. Number of standard deviations. Like for example, if z is equal to 1.5, it means it has covered, the z will be over here, 1.5. 1.5 standard deviation. If it is 2, then 2 standard deviation. If it is 3.5, 3.5 standard deviation, it may be over here or far away from here, 3.5. So it gives you the number of standard deviation whenever you calculate a z-score from this formula. That will give you number of standard deviation. The z-score or the number of standard deviation. This is the Z table where you can look your area, for area the value, and for the value the area. For example, in the previous example, the Z score was 1. So the area 0.3413, and for minus 1 the same area 0.3413. But the Z with minus symbol will go towards the left and the Z with positive symbol will go towards the right. That is the only difference. What is the probability of getting a math set score of 575 or less? Mu is 500 and sigma is 50. 500 and less means that those people who score 575 and less. 575 less means if the mean is 500 and a person is standing over here with 575, what is the probability of getting the score 575 or less? This is the score, the whole percentage of the people who will get 575 and below score. So let's see on the slide. This is the formula. 575 is 1.5 standard deviation. That is a score of 575 is 1.5 z standard deviation above the mean. So when you come back are below 575, you have to calculate the whole area up to 0 on the curve, like up to here. You have to calculate it from here to here. That is given the curve. So 1.5. So the area from here to here is 0.4332, and the area from here to here is 0.5. So the percentage of student who will get less than 575 or 575 and less, that will make this whole area, and that becomes 0.9332, or when you convert into percentage, that becomes 93%. Another example, suppose the score in a test of a normal distribution with mean 70 and standard deviation equal to 5. Assume the student need to get at least 60 in the test to pass the course. What percent of the students who take this test are able to pass the course? It means that determine or calculate the percentage of those students if the mean is 70 and the passing score is 60. What is the percentage of the student who get 60 marks will pass the course? So those people who get 60 and above will pass this course, and it will make their percentage. This is the percentage of those people who will be able to pass the course. Now through the formula, it becomes -2 on 60. If the individual X score is 60, the Z score is -2, means 2 standard deviation below the mean. And on 2 standard deviation Z score, the area is 0.4772. So the area under the curve between mean and this is 0.4772, and to the right side is 0.5. We add the 0.4772 and 0. And it comes to 0.9772. Thus, 97.6% are able to pass this score. When the passing score is 60 marks. So 60 and above, those students who get 60 and above will pass this course, and the percentage is 97.72%. What percent who take this test are able to pass the course with a score of at least 65? At least 65 means those students who will get 65 and above. What will be the percentage then? 65 and above. So here it has been solved over here. Mean is 70 and standard deviation is 5. Then with the formula, if you calculate these are 60 and these are 65. With 65, if you calculate Z is equal to X minus mu over sigma, that will become 65 minus 70 divided by 5, and that will become -1. So at -1, at 1 standard deviation below the mean. So it will it has an area of 0.3413 in the Z table, and this area is equal to 0.5. So those students above the 65, you have to add up these two areas, this area and this area, and that will make how much? See how much? It will, student getting score more than 65% is this area. So when you add up this area, that will become 84.13%. What person who take the, are able to get score between 60 and 75? So mean is 70 and standard deviation is 5. You have to calculate both the Z score for 60 and then for 75, and then you have to add up the area. If it is above the mean and below the mean area, then you have to add up and determine the area between the two Z score. And that will, when you convert to percentage, that will bring you a percentage of the people who will get between 60 and 75. So this is what x1 minus mu or standard deviation -2, and for another it becomes 1. So between 1 standard deviation and -2 standard deviation, here is the area 0.4772, and here is the area at 1 standard 0.34. So adding up together these two, it will become 81.85%. between 60 and 75. Mean IQ score 100 and standard deviation is 15. Formula: if IQ score of a person is 110, how to compare him to the rest of the people? If the normal people have mean score 100 and these people have got 110, means they are more intellectual than those people who have score 100. Their intellectual level is above these people. So now let's do it on the slide. This is 0.67. So they will fall over here. 110 is over here. They are above the average people. Now what is the interpretation? When an IQ of 110, your z-score is 0.67. Go to z-score table and find z-score for 0. The area between the z-score and the mean is 0.2486. This is the area on 0.67 in the table. We know that the area up to the mean is 5.0, and we know that the area or score was above the mean. So we add the two numbers to get a total area of 0.7486. Therefore, your percentile rank in terms of IQ is 74.86, which means that your score equal to or greater than 74.86% of the population. When you compare this person with the rest of the population on the basis of the rank or percentile, so this person is in that group of the individual, in that group of people who have scored 74.86% or percentile, and they are in this group. So below them, there are 74% people are below them, and some of the people are above them, almost 25% or something like that. Now assume that mean weight of American males between 21 and 30 years old is 156 pounds with a standard deviation of 8 pounds. If select a male at random, what is the probability that his weight will be 160 pounds or more? So z-score, first we have to determine the z-score, and the z-score is 0.5. 0.5 in the table will carry an area of 0.195 if you see in the table. And this is the area. If you select a male at random, what is the probability that his weight will be 160 pounds or more? If select a randomly an individual, what is the probability that his score will be 160 pounds or above his weight? So this is the area which will tell you 160 pounds and above. So that becomes 0.3. You have to subtract from 0.5 this area from 0.5, and this will give you this one area, and that makes 0.3085. So probability that mean weight of American male between 21 and 30 years old will be 160 pounds or more is about 31%. If birth weight in a population normally distributed with a mean of 109 ounce and a standard deviation of 13 ounce, what is the chance of obtaining a birth weight of 131 ounce or heavier when sampling birth records at random? What is the chance of obtaining a birth weight of 121 or lighter? Lighter means below and heavier means above. Now let's do it. Of getting a baby of 141 or heavier or more than 141. So this is the z-score on 141, and above 141, what will be the percentage? So you have to take this one area. The z-score is 1.69, and at 1.69, what is the area? The area is 0.45. You have to subtract this 0.45 from this whole 0.5, and that will give you this one area, which becomes 0.05 or 5%. And now lighter, 121 or below. So you have to calculate the z-score for 121. So the 121 is over here, and below 121, it makes this whole portion. It makes this whole portion. So for a z-score 0.92, the area is 0.3212, but this area from here to here is 0.5. So you have to add up, because you are making probabilities of 121 and below. So add up these two areas, and that makes 82.12%. And these are the homeworks. You have to do it by yourselves. The probability of finding a hobbit taller than 125, similar, the same concept is there. You have to apply the z-score, and then you have to calculate the z-score for 1 to 5. 1 to 5. If a cholesterol level of men in the community is normally distributed, the mean of 160 and a standard deviation of 30, identify any outlier for among the following measurement. I am doing the first one for you, and whether it is an outlier or it is normally distributed, and the rest of the question you have to do yourselves and find whether these are outliers or not. So on the basis of z-score, we can calculate the outlier. Z is equal to x minus mu over sigma. You need to have mean and then the standard deviation and the x. So we have a mean of 160 and 30 is the standard deviation. To 448. To 48 minus 160 divided by 30, and that will become, let's do it, that will become 248 minus 160 divided by 30, and it becomes 2.9. If the z-score is 3, mean this value, if it is 3 or below 3, after calculation, that comes a normal distribution. If this calculated value is more than 3, then it will be an outlier. Let's do another greater value. For example, 300. Whether it brings a z-score of 3 or more than 3, and whether it is an outlier or not. So 300 minus 160 divided by 30, and it will become 140 divided by 30, 312, 36. So it becomes almost 4.6, and it is more than 3. So it becomes an outlier. And similarly, you have to do the rest of the question, whether they are outlier or not. Thank you. And this is a homework. A researcher was interested. Homework 2. You have to do it by yourselves.